Hi guys, and welcome to HSC Chemistry. Chemical Monitoring and Management number 18. We're looking in this particular video at chlorofluorocarbons. To look at the CFCs, we need to sort of backtrack a little bit and just get a reminder of the group to which they belong, and that is the halo for halogen alkanes. These particular compounds are carbon compounds in which one or more of the hydrogen atoms of the alkane have been replaced by one of the halogens. So these are the group 7 or 17 elements, depending on the way that you structure the periodic table. So you can see in each of these cases we've got a methane where one of the hydrogens has been substituted for a chlorine, and so therefore this becomes chloromethane. If we substitute 2 more of those hydrogens for chlorines, then we have a tri or 3-chloromethane. And you can see here we have a bromine substituted where there are 1, 2, 3 carbons in the main chain. So it's a propane, and the bromine is on the second of those. So 2-bromopropane. There are a lot of rules associated with the naming of the haloalkanes, and we will have a look at those as well. And that will help you to name very complex ones, such as 1,3,3-trichloro, 1,1,3-trifluoropropane. So then to the chlorofluorocarbons, and these are a specific group of those haloalkanes in which all of the hydrogens have been replaced by chlorine and fluorine. So there are no hydrogens left. CFCs were widely marketed as freons, particularly 11 and 12, and we'll have a look at those in just a few moments. In fact, you can see those here. CFC number 11, or freon 11, was trichlorofluoromethane. So methane 1, trichloro, and fluoro would look like that. This was one of 2 compounds which was used in refrigeration and air conditioning, also in the production of insulation and as an aerosol propellant. The other was dichloro-difluoromethane, so exactly the same as the one above, except this time 2 fluorines and 2 chlorines instead of 3 and 1. Same thing, same use, and same derivative. So you can see the names actually come from the fact that each of these is a 1-carbon compound, and what's been attached to it are all of those chlorines and fluorines. One of the other common freons was 1,1,3, which is 1,2,2-trichloro, 1,1,2-trifluoroethane, and it was used for cleaning circuit boards. The problem with these is they interact with the ozone in the ozone layer and have been breaking it down. And so in about 1996, there was a ban placed on the production and use of these compounds. There's some pretty significant rules that we need to look at when we're naming haloalkanes, but a couple of these are probably important. Go back and have a look at these later on. The first important thing to remember is it's alphabetical. So bromo before chloro, before fluoro, before iodo. If you've got more than one, then we use di, tri, tetra, and so on as we have usually. The rest of the rules are pretty consistent. So you're always looking for the longest unbranched carbon chain with the halogen. You can sometimes have things like methyl groups, but we won't look too much at those. There's a few of them around, and we'll have a look at some examples, but not critical. So any side branches, and then make sure that everything comes in the alphabetical order. Number the longest chain, and then look at the lowest set of locands. So that is where they are located. Okay, so a 1-bromo would always be better than a 2-bromo, and so on. Place them in front, so 1-bromo or 1,1-dibromo is the correct nomenclature. And when we have more than one, then we always look at lowest combinations of terms. Okay, so a 1-bromo, 2-chloro is better than a 2-bromo, 3-chloro, and so on. The only other thing that's important is that if there's more than one possible name, then we need to go to the alphabetical arrangement to make sure that those numbers are the smallest we can get. So then if you were going to name these compounds, what you would look at is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's a hexane. The chlorine is located on either the fourth or the third, so we go with the smallest number, which is 3-chlorohexane. In the second example, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the chlorine is 2 or 4, the bromine is 2 or 4. How do we determine which is which? We go alphabetical. So it's 2-bromo and 4-chloro and then pentane. In the third example, we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have 2-chloro or 5-chloro. Here we have 4-bromo or 3-bromo. In this case, 2 and 4 are smaller than 3 and 5, so this is the one that we go with, but we still put the bromine first. So it's 4-bromo, 2-chlorohexane. Thanks for watching.